Hello everyone, this is wattsup, and this video will be Half Coil Syndrome 2. Okay, taking from just a recap from Half Coil Syndrome 1. Turn on the scope and turn on the frequency generator. We're just going to recap here on what I showed you in Half Coil Syndrome 1. So here I'm just going to connect this first coil here that I did the last time, just to give you a good rundown on what things are. And let me just get this here, this little tape head that I'm using to go across here. Let's get here. I'm going to put this up to let's say we put it up to 740K. This is 50% duty cycle, and it's a sine wave, so this is an AC signal, and as you're bringing it across you can see it go lower and lower. I could reduce the voltage divider on the scope. I'm using my channel B so that I don't have this thing coming out of here for this demonstration. So here, that's the magnetic influence at the pulsed side, positive, and then we're going down towards the negative, and we get less and less. Okay, and what I showed you then was if I put another coil of the same winding characteristic and put it in series with the first one. We're just going to go and test this out here, and this goes here, and now let's put this thing back on here, and you can see that as I'm going along there is a decrease, but it's far from being a flat line like before. Now so this is what I showed you in the first video, and this was a very preliminary thing that I did a few months ago, just before I took several months off. Okay, so we'll take this out, and what we'll do is we're going to try another type of coil so that we can expand on this, and hopefully some of you will catch the importance of this, and hopefully it'll help you work around it. So here I have a little coil of X amount of turns, and this coil is on a ferrite core. This ferrite came from a regular antenna for use for radios, and I just wound X amount of turns. Didn't really care how many. It's not really the amount of turns that's important, or the type of wire that's important. It's just the effect that's important. So here I'll put the negative here, put the positive here, and with my little doohickey you can go ahead and check that out. So here again you can see that as I'm going along from the positive to the negative, I get to very near a flat line. The effect here is probably, I'll get into that afterwards just to let you guys know what's going on here. So here you see you have a flat line. Okay, now I know that this coil here is identical to its counterpart that we just did before, and when I put it in series we saw a greater amount of energy being dissipated in the first coil. So I'm going to take the same one. I'm going to take this one here, and I'm going to put it in series with this coil here. So we're going to go like that, like this, use this jumper, come around, and just connect it up over here. And here we go. Okay, so now we have the same coil that I was using before on this coil that has a core. Now let's just check it out at the same frequency. So we have here positive side, so we do get an effect, but it's a lot less. Okay, and I'm getting more of the percentage of the total pulse happening on this core. Not that much. Let's change this coil for something that might have more windings. So let's just put this one here, this little coil here, which is an air core. Okay, put that there. Now with this air core with more windings on it, yeah, we're starting from higher up, and when I get to the end, you see how high I'm still at. You got that, guys, you got that. I hope a lot of you just understood what I just showed you here. You see that? Okay, we'll take this one off and we'll put one on that has another air. This is just a spool of wire. I managed to get the last piece of the wind, so I'm using this as is, and we'll do the same thing. So I'm getting a little bit more, but anyways, it's just to show you guys that I'm going from positive to negative now, and look at this. Wow, pretty good. This whole first coil here on this core is active. So the whole coil is changing from positive to negative, or positive positive, because this is the way it goes. Okay, so I'm going to take this one off, and I'm going to try a different type. Now this one here, this coil here, it's just a regular coil for a little AC motor, and it has a core. It has a winding. I don't know how much of a winding it has, but I know it has a core, and I know that this has a core. And it seems like when your coil is on a core, if you want to use an extended to remove the half coil syndrome, you need a lot of wire if it's an air core, and you can use probably less wire if it's a coil on a regular core. So here we will put the negative here, and I'll just take any one of these two here. I'll take the red one here. Okay, put that across, and there you go. Come bring it across. So we see under the same pulse conditions, and this, by the way, this is like an AC sine wave right now, and here if you want I can put it on pulse, square wave pulse, and you'll be seeing something a little different because it's a square wave, but the idea is the same. See that? I hope some of you guys are understanding this. The importance of this little video should be obvious to a lot of you guys that are doing over-unity research. Okay, so from there, even with my pulse, my square pulse, I'll put it directly on here. Get this out of the way, and we're just going to try it with the square pulse wave, just to show you that even a square pulse, will suffer from half coil syndrome. So you're getting very near a flat line at the end here. So what does this mean? Let's see if this thing here, I can get this here for you. So I made this little paper here. Now what this shows is this is a DC pulse, and the bottom line here is the length of the wire in your coil, and the top line here is the magnetic influence that it is dissipating on its own or to a core. Okay, whatever it is, doesn't matter. Okay, this is the magnetic influence that it's producing. And as we're going along here, if this is the pulsed end, and this is the common end, or the positive and the negative, and as we're going along here, it's decreasing. So by the time you get to half of the length of the coil, this is the energy that's left to be able to dissipate in 1/2 of the coil, which is about a quarter. You have about 75% here and about 25% here. So 75% of the energy is dissipated in the first half of your coil winding. 25% is dissipated in the last half. I hope some of you guys understand what I'm saying here. Now, under an AC pulse, this is not a common or a negative, this is now a neutral. And this is your hot side. Okay? And what's happening is your hot is going up, down, like a regular sine wave, up and down, up and down. But throughout the length of the wire, what's happening? Same thing. We're getting 25% of the energy is being dissipated in half the length of the coil. And this is why I call it half coil syndrome, because every coil that is pulsed on one side will have this problem. And whether it's a motor, whether it's a generator coil, regardless, they all have the same problem. And I think this is one of the reasons Tesla, he must have known this. I'm not sure if he did. I can't find anything in his literature that speaks specifically of this. But probably instinctively he knew something was wrong with the basic DC, and he tried to augment or rectify the problem by inventing AC. So physically speaking, if let's say this pen here was a DC pulse. So a DC pulse, that's your flat line, and all it's doing is it's just going up like this, and it's coming back to the flat line. It's just going up like that. That's all it's doing. So throughout the length of the coil, half of it is only dissipating 25%. And your AC, you've got your neutral here. This is your hot side, and what it's doing, up and down, up and down, up and down, up and down. But you still have half of that coil that's not doing much. Okay? So, the ramifications of this are what? Let's say this core was a toroid, and or whatever, any other coil, any other core, it doesn't matter. And I have X amount of turns as a primary. I want to make sure that each one of these turns is going to be producing a maximum amount of impulse to the core. Otherwise, you know, what's the point? Half of this is only dissipating 25%, and that's a lot of real estate on a core to take up for only 25% of the energy dissipation. So, okay, I'm going to stop this here, or let's see. What else can I wanted to show you something else, and this is in the half coil syndrome. Let's say I brought down my pulse to let's say just 2 hertz. And I'm going to take a compass here, take a compass here. I hope you can see that. You see both are being affected by the pulse. One is on the negative side of the core. The other is on the positive side of the core. But then, you know, I mean, how can that be? How can the negative side compass still move around like that when we can physically see that the energy dissipation, well, right now we won't be able to see it because I'm only at 2 psi, so this scope here will not be able to catch it. But maybe if I bring down the pulse a bit and bring up the volts divider, you can see a pulse there. You can see it very weakly. And if I bring it across, the pulse is just gone. You just can't see it. I mean, it's just not there compared to being able to see that small spike. It's a small spike. It's not a big spike. I'll bring down the volts divider a little more. Okay, here. Now you can see it a little better. You can see that 2 hertz spike. And then let's go on this side. No 2 hertz spike. So what's happening here, if we can observe this, is in this core, 75% of the energy is dissipated by this half here, and 25% by this half here. But it's on a core, so this 75% is still permeating somewhat through the core. It's the core that's getting this compass on the right hand side to move around. It's not as much the coil itself. Whereas on this side, well, you have the strongest coil and then you have the core as well. And you know, the movements are a lot more controlled. Okay, so this is where we are at. So the movements here are a lot more controlled, and here they're a lot more loose. It's hard to tell because it's a visual thing. So, you know, for years and for decades and decades, you know, we're looking at compasses, we're looking at coils on a core, and we're thinking, wow, this is the south field, and this is the north field, and, you know, that's the core. So the core has a north field and it has a south field. But what I'm trying to say is that most probably there's no such thing as a north and south field. There's only, how can I put it? Because now we have to say north or south, or north and south. Let's say that this here was a south field. All there is here is a south field. The north field here is practically non-existent, if you want to call it a north field. This is really a coil. I mean, even magnets, even cores, all they can produce is one field. And what we're seeing here is one side of the field and the other side of that same field. It's not two different fields. It's the same field looked at from the counterclockwise turn here and the counterclockwise turn here, which is the opposite, which becomes the clockwise, if you look at it from each angle like this and like this. But it's the same polarity happening here. There is no north and south polarity. Just like you're wondering, you know, on Earth, I mean, we've got a core in the middle. Why should that core have two polarities? It's the same polarity, but in a different, one is clockwise, the other is counterclockwise, but it's the same polarity. Why would you need two polarities? You don't need two polarities. So what I'm thinking here is this core here, the actual polarity is coming up to about here, and then it's going down, 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 but it's the core itself that's carrying it over to this compass, and that's why we see it. And we, from the outside, think, oh wow, you know, the field is going all the way down to here, and you know, this now north field is coming here, the south field is coming here. So this is something that has to do with half coil syndrome, and it has to do with spin conveyance. and I'll be getting into spin conveyance and more on half coil syndrome. I'll show you some more concrete examples of how to go about working to eliminate half coil syndrome from your pulse devices. Because right now, if you're pulsing a primary and you have a secondary on that coil, it's already lost. It's already a checkmate. There won't be any overunity. There just cannot be. And the main reason is, if I took, let me just grab here any transformer here with 2 coils. Okay, let's say I just took this transformer here. Okay, now let's say this is the primary and this is the secondary. If I pulse the primary in a way that, let's say I have an energy level of 10, whatever that means, it's an energy level of 10 that I'm pulsing on here. If I produced an energy level of 11 on the secondary coil, which is this one here, well, the secondary just became the primary. And the primary will be pulsing back into this primary here. The secondary would be pulsing back inside the primary. And it would be probably killing the dipole. That's what we call is killing the dipole. There's a certain way that we have to go about pulsing our coils that we're not there yet. We just don't understand that. We're working with checkmated devices to start with. All our transformers, all our industrial transformers, all our motors, they're all checkmates to start with. And what I'm trying to research here and my orientation is to go past that and to find ways to circumvent this situation here. Okay? So this coil here, that is a primary, still suffers from half coil syndrome because only half of these turns will have 75% of the energy, the other half will only have 25%. Same thing if this was the primary, half of these winds would be dissipating 75%. So when you're doing a device like this, it's always important to know if it's multi-layered, which I strongly do not recommend. But if they are multi-layered, you always have to create the changing pulse on the side that's closest to the core. Okay? Meaning, don't put your changing pulse on this end. You put your changing pulse on this end. And this is the side that's going right in there and it's starting to wind on the core. Okay, so I'm going to stop this for now. And I'll be making another video hopefully during the day today or tomorrow. So enjoy.